It is easy to be impressed by the skilled movements of trained professionals, surgeons, athletes, musicians, but many of us don't think much about how complex and important our basic everyday movements are. Our bodies are specialized systems that respond to and interact with our surroundings. Our movements need to be fast enough to keep our bodies away from harm, maneuver a vehicle, hold a conversation with a friend. This means that many of our movements need to be executed more quickly than is possible with voluntary movement or reflexes. Our movements need to take into consideration the physical constraints imposed by our muscles and joints and the objects around us. Our movements need to be smooth and precise to minimize energy cost and to adapt to changes in our environments. Human movement is so complex that it has not yet been matched by computers and robots. One common type of movement that is important to many of us every day is standing. Standing is an active process that requires constant and very fast adjustment in order to maintain balance. This dynamic activity relies on information from our surroundings and is sensitive to changes in what we see, feel, and hear. In the Sensory Motor Neuroscience Laboratory, we study how human movement is related to the sounds that we hear. In my research on balance while standing upright, I'm investigating which types of sounds help stabilize our balance. So just as a loud sound can startle us and cause an abrupt destabilization, predictable sounds such as music can lead to stabilization through subtle and involuntary synchronization with the rhythms in the music. I have also found that white noise can stabilize balance. Introducing noise to the nervous system can increase signal transfer through a process called stochastic resonance, and this has been shown in vision, audition, and mechanical sensory perception. It has already been shown that vibrating mechanical noise applied to the soles of the feet can improve balance, even if this vibration is so subtle that it can't consciously be felt. We are showing that auditory noise has the same stabilizing effect on balance by increasing feedback that aids in balance mechanisms. We believe that this research will lead to inexpensive and effective fall prevention therapies for people who struggle with balance. We use methods such as motion capture, EEG, and transcranial magnetic stimulation to contribute to the scientific understanding of sounds and movement. This research also has the potential for extension to clinical applications. Our specialized ability to move is easily taken for granted until something goes wrong. But because human movement is influenced by so many factors and can adapt readily, there is hope for those with movement and balance disorders. Thank you.